Last section of the chapter, we're going to be looking at solving equations that have the radicals or the rational exponents that we looked at earlier in this chapter. So if we see equations that have square roots, cube roots, or x to the 3 halves, how do we handle that? Okay. Just for review, real quick, and to kind of see what it is we're doing when we try to solve some equation, let's look at one that we've done before. So here we have x minus 1 squared minus 4 equals 0. This is very related to finding inverse functions because we're trying to find what x gives us that 0. So it's not that different than if we were to have this just as a function equal to y, and we're trying to find what x gives us any y. And when we solve an equation, we just go through and try to undo everything that's being done to that x. So as we look at this one, the first thing that we can undo is the minus 4. So we add 4 to both sides, right? So we have x minus 1 squared equals 4. Well, then the next thing that we can undo is the squared. How do we undo something squared? We take a square root. All right, square root of that on the left leaves us with just x minus 1. On the right, square root of 4, don't forget the positive and negative, so we have plus or minus 2. And then the last thing to undo is this minus 1. So we add 1, we add 1. So x is either a positive 2 plus 1, so that's 3, or x is a negative 2 plus 1, which is a negative 1. So 3 and negative 1. So when we solve an equation, we're really just trying to undo everything that we see. So keep that in mind as you see newer things in there, like a square root, cube root, or these exponents. How can we undo those other operations? So let's solve this one, where we have square root of 5x minus 9 minus 11 equals 0. First thing to undo is that minus 11, so we add 11 to both sides. So plus 11, and we have square root of 5x minus 9 equals 11. The next thing to get to that x is that square root. That's the next thing in the way. So how do we undo a square root? What's the opposite of a square root? Squaring, right? So we square both sides, and squaring a square root gets rid of that. So we have 5x minus 9 equals 11 squared is 121. Next thing to do is add 9. So 5x equals 130. And divide by 5. Once you get to this step, really, shouldn't be anything new. Shouldn't be much of a problem to solve any of those. What does that end up being? 26, I think. Check and make sure I'm right on that. But again, just undo everything that you see there. If you keep that in mind as you solve, you should be able to solve just about any equation with any type of function that you've seen so far. Let's check out this one. It has a cube root in there. So we have a cube root of x minus 10 equals negative 3. Can't do anything with that cube root yet, so don't cube both sides. The first thing we would want to do is get rid of that 10. So add 10. Cube root of x equals 7. And then how do we undo a cube root? We do that by cubing both sides. So a cube root cubed on that left side just gives us x. And 7 cubed, is that 343? Let's check that quick. Yeah, 7 cubed is 343. So there we go. And lastly, this might be the most frustrating one. Here we have a square root, but we have an x not in that square root. So we need to get rid of that square root before we can do anything, because we can't add or subtract that square root, or the x into that square root. So again, first thing that we need to do is square both sides. And we have to be careful here when we square that right side with the x minus 10 because that whole side needs squared, so we're going to have to FOIL. Okay, so square both sides. That square root squared is just going to leave us with 44 minus 2x. And on that right side, when we FOIL, we're going to have x squared minus 20x plus 100. So now we have a quadratic that we're going to have to solve, but before we solve that, we need to get that left side moved over. We want this equal to 0 before factoring would do us any good. So let's subtract 44 from each side, add 2x to each side. So 0 equals x squared minus 18x minus 56. That shouldn't be minus 56, that should be plus 56. That does give us a positive. So let's try factoring. Let's see if it does that first. If it doesn't factor, then remember the options that we had from Chapter 4. We could try completing the square. We could use the quadratic formula. Those are all things that we can turn to if this does not factor. But let's try factoring first. So we have x and x. We need to multiply to a positive, add to a negative. So both have to be negative. It's anything multiply to 56 and add to 18. If you think that one through, it looks like 4 and 14. 4 times 14 is 56. Add those together and we do get 18. So from here, from each of these factors, we get x equals 4 and x equals 14. Okay? Now here's a problem that we haven't really had since we did absolute values. When we have one like this, where we have that x outside of the square root, and we square both sides, we might get an extraneous solution. We might get a solution at the end where one of these, or both, might not actually work. Maybe both of them work. Maybe neither of them work. Maybe only one of them works. The reason for that is we started out with a square root of x and an x. By squaring both sides, we've kind of increased the degree. Right? And if you think back to the fundamental theorem of algebra, the degree tells us how many solutions we might have. So by adding something to the degree, we've maybe added a solution, so we might not have something that works back in the original. So what you need to do is take 4 and plug it into the original function, square root of 44x minus 2x equals x minus 10. So not including the squared or these parentheses anymore. Okay. So plug 4 into that original, plug 14 into that original, and see if one of those maybe doesn't work. Pause for a second, check those. So when you check those, it looks like 14 works, but x equals 4 does not. Right? X equals 4 gives us a positive 6 on the left and a negative 6 on the right. So 4 does not work. And again, that's an extraneous solution that we'll have to watch out for in the cases where we have an x outside of our root like that.